visible now?
Yes, sir, it is visible.
Okay, thank you. Thank you. So I think, let me introduce myself. I think you already introduced. I'm Nitesh Goyal, working as a director in Samsung Research Institute. And I'm like, my privilege to be part of the security and privacy issues and the countermeasures in the era of AI. So my session topic is from transparency to trust, explainability as a security tool. So let me like go through like the background about the AI, like why don't we trust AI? Why transparency matters, the trust challenge. Imagine like just in the real world, like we want to hire someone for important job, but they refuse to tell us how to make decision. Would you trust them? Like for everyone, like this is a common like example of real life. When we want to hire someone and we don't know the job of that person, like how can we hire them? That's going on with that's how like many people feel about the AI system today. Like AI make a decision, but we don't know why. That's a bigger problem for all of us now. Like whatever we have prepared, what AI makes for us, like we don't know how it come, where it came from. We as an end user, like we don't know how to trust this AI system. There are a lot of issues with that, like black box problem, where we can't see how AI make decision. Like if I want to do some task for me, like or maybe like for others, we only get an output like hey, yes or no, or maybe like it's possible, not possible, but we don't know the outcome of like how it get done. Also, we have a lot of hidden biases on this, like AI learn from data, but that contain unfair patterns like that some area of like data will help us to identify, but some area like are biased for us. But when the output comes to, we never know what area data focusing on. Unpredicted outcomes like AI sometimes gives surprising or wrong answers. Like that's very common AI problem for all of us. When something false happen, we don't know what to do on that. Also, security risk is one of the things like we talk about in later slide, like what are security risks when the AI will how to detect and prevent attacks for us. So without transparency, trust disappears, and without trust, we can't safely scale AI or protect ourselves from the risk. There where the explainability comes in. Now talk about what is explainability. Explainability is in AI making the invisible visible. That's definition says. So it means like understanding why an AI system make a specific decision, not just accepting answer it gives. It's having an AI system that tell you the answer, but showing reasoning step by step. Like we discussed in the previous slide, we talk about like black box problem, where we get an output from an AI system, but we don't know where this output is coming, what's the reasoning behind that. So explainability will help us to identify the reason step by step, so we can understand how the output is coming. So explanatory key concepts say like transparency, see how the AI thinks. So we need to understand how this AI system think about as a problem and what output they're giving. So it helps us to understand the transparency and trust. Interpretability, like AI understand the logic, like the way the human explain, it's not a technical jargon that explain to us. Accountability, like someone is responsible for AI decision, like what output is coming, how much accountability, like if some errors coming, how we can fix that errors. And trust is very important. Like transparency, only trust come with a confidence. Like take a real life in scenario. Like you apply for a loan. Okay, which response do you prefer? Like your loan rejected or your loan is rejected? So it's a common question to everyone. Like just think one AI system we develop it just for a bank loan, and we got output like your loan is rejected or your loan is rejected because of some reason. So what do you guys think? Like, what will the preferable answer for us, like as end user? Can somebody answer this? Hello. Hello.
Yes, anyone from the audience?
Okay, not then I will be behalf of all of you. Like for me, the second answer is a well-defined answer. So you can say like that the output from the AI system says your loan is rejected. But this is like a black box problem for us. Like we don't know how my loan gets rejected. So it says like your credit score is 580, that is threshold like below 650, and debt to income ratio 45%, like limit is 40%. So you can reapply after improving these factors. Unless we don't know how this AI system respond to us, we cannot take any action beyond this. So we cannot rely on the AI system where it says, hey, your loan is accepted or rejected. Accepted, like we are a little bit greedy about that, so we accept it, like, okay, this is positive result for us. When it's rejected, what's the reason for that? Explainability help us to define the reasoning for us so we can take a necessary action on that. Now we talk about the explainability, like protect us. We cannot like do a trust and security inseparable. These two parts cannot be separate together. This is part of like one system. When we want to do something security, as my topic says, like explainability as a security tool, I cannot do it without a trust. I need to trust this AI system, then the security comes on that. So explainability help as a bridge between them. So it's a bridge between a trust and a security. If we trust on the system, AI system, then security will always be like we can do something for the security, but there's no trust on the AI system, we cannot do on the security on that. So I'll talk about much about it like that. How explainability is threatened, like two terminologies, just safe and dangerous. In the safe, we talk about audibility, like reason AI decision for fairness. If I will not get any answer for the like AI system, how can I be audit to do something on that? If I always get a positive or negative, I cannot take any decision on that. So this explainability help us to identify the decision for the fairness. Second, error detection. If AI makes a wrong decision, something like me, take example, like we are applying for a loan in the earlier slide, we talk about this, and it says like, hey, loan is rejected. If without understanding the user need or like customer like problem, if it say rejected, then we cannot always rely on the AI. It's good for a like home loan system. Talk about a medical case like where we have some cancer disease, we have a critical system. In the critical system, error detection is a very, very important part. Like if until the doctor doesn't know how the disease coming and what are factors for that, they cannot take a decision on that. Accountability, like we need a clear ownership, means faster response relative for failure. Like it should be understand the problem and try to fix it. Like if it not fix it, so accountability will helpful for the end user, but the one who develop AI system, both of us. Like so, if I know the problem like coming from the AI system, and if we can pass on, then AI system can improve. This explainability can help us to understand it more. Confidence, like transparency, build confidence in critical application. I already talk about the medical case. We'll check more on the later slides. What happened without explainability? This is a dangerous spot for us, like because in the era of AI world, like where a lot of things are developing, we don't know like how somebody developed this. Take example of like maybe in the USA, if somebody developed for the skin disease, I'll talk about more about this. Like, and they collect set of data for the white people, and they didn't select a set of data from the black people. And then the black people like diagnose something on that, always like result in some failure, like some skin disease, because they don't have a data for this. Until the end user doesn't know about this, they cannot like they always we can't believe or doctors can't believe on the system. So there are a lot of undetected bias on this, like hidden in black box decisions, where we don't know what's going on in the background. Also, there are a lot of chances like bad actors, like take example of like IoT system where we normally like allow like users to give a command in the IoT system like, hey, something is going on, and then some intruder comes and in between like provide some command to us in the AI system, and it's someday break the AI system. We need to protect that as well. Silent feature, because broken AI system continue without operating undetected. No resource, user can't challenge unfair it, because we already talk about this like that. If we don't know the AI system, how the output is coming, we cannot like argue or comment on that AI system, because we just believe on the output what they're giving for the AI system. Security vulnerabilities, this is always like attacker can exploit unmonitored system. It can be like dangerous for all of us, because until we don't know about the system, how to develop, what are security measure they have taken, we cannot take like any decision on that. So now we already talk about like trust and security cannot be inseparable. It's explainability is the bridge between them. Let's take example of a healthcare scenario where an AI system diagnoses disease from the medical image. This is some aspect, and without explainability, I'm just trying to like mix up thing like what I explain the theory. It comes as a practical example. So everywhere in this like call can understand how we can relate things, because When we consider an example, it's very easy to understand a use case scenario. Like it's difficult like to otherwise understand that. So just take an example like without explainability, like in healthcare scenario where a AI system diagnoses disease from medical image, it's just say patient have a disease with the old like, AI system without explainability. And then with the explainability, it says a patient likely has a disease X because the tumor size 5 centimeter indicate and location include 95% of the cases. So when the doctor get this type of data with them, like for them, it is an easy decision to trust on the AI system. Hey, it's identify some part of that. So we will talk about the tools used for the explainability, how it helps them. Sorry. Also like trust label because doctor is not secure. I already talk about that because if we get the data like this patient has a disease X, doctor is not sure like what disease they're talking about, what parameters they have taken because in the medical field it's not easy to just trust on the facts like hey, yes or no, we can do that. But in the case of explainability, doctor can verify, hey, what our AI system is giving us, what they have with expertise, they can mix it and they can understand the problem very well. This it's sort of like misdiagnosis, but doctor can catch an error because they can say, hey, tumor is there, and then we can find 91 cases matches, they can take a decision. Security because bias go unnoticed. But in case the bias detection possible because we know the output coming from that. And we can doctor can see, hey, this might be taken from one area, one part of this. This is not good. Like we need to rebuild the system again or rebuild the accountability. Nobody responsible like without explainability. Nobody responsible for this. But here the doctor have a clear responsibility because they get the data, they get an output for this, they understand the reasoning for this, and then take a decision. I hope everybody is understanding that because I want to why I'm giving an example because it's more clear the fact like what this explainability means for us. Otherwise, like theory is sometimes difficult to understand. That's why I'm just putting a small example to clarify everyone like, hey, what the means like without and with like. So explainability says like better outcome, safer patients, and protected liability. So these all terms helpful. So you can say earlier AI system and with explainability, how things are helping us. So we are not sort of developing everything from the scratch or something new. It's just part of the AI system. Whatever the existing AI system, we need to add on this and make more trust, confident, and more secure AI system for all of us. This is why like explainability is not optional. It's essential infrastructure for secure AI. So for everyone, like it's not optional. Nowadays, like LLM into in practice now, but talk about like earlier AI system where it's not optional. We need to like sorry, I think some interruption there.
Sir,
Like,
please
really sorry
continue.
there. Yeah, okay, thank you. Now we talk about the basic philosophy of explainability and their like work scope, how it works with some basic example. Now I went for some case studies like and with the case study it helped me more to understand then and versus now like what happened. So I've taken the three examples of like healthcare, finance, and security. With the healthcare, like I checked one of the example like a skincare melanoma detection. Without like before explaining 2015-18, this models is given to the doctors, and then whenever we get like output for that, it's always a black box decision for a doctor. Like they cannot take any decision for the doctors for this because this is before explaining, there's no reasoning for that, like how this output coming. It just say skin cancer. We all know when we develop an AI system, it's all based on data set. So maybe one part of data we have collected and then other part we have skipped it. So one part may be the bias for everyone. So without like having a fact or reasoning for that, doctors can understand this fact, like how we have taken this decision. But after explainability, like 2019-25 on this like case study, with visual attention map, doctors can see why a model think a lesson is like many, so they understand it very well. And we got a case study update where say like 2.8% improvement in human AI combined diagnosis accuracy. This is a fact from the case study. All the links in the below, like I'll share this deck to everyone, where this case study links are mentioned in below. And also trust and user decision support. so sharply, because with the help of these all these explanatory tools, it helps us to identify and see it like in clinical guidelines. It's not 100% cure, and we cannot say it's 100% prevention, but it's a wellness thing for a doctor to advise somebody like, hey, we identify with the help of AI system, it's helpful now. They find it secure, they find it like trust on that. So with the help of technology, its healthcare part is a little bit like people use it all now. Taking an example of finance, like where we have a credit card fraud detection. Before explainability, it's again a black box because somebody used random forest like algorithm and caught more fraud and left investing in regulatory frustrated, no rationalized or flag transaction. And there are possibility of high rate of false positive. Let me go through one example like where we have a conversation where we have a conversation with the bank guy, like he talk about so much things with us. And suddenly when they say OTP, we suddenly feel like it's a fraud. Maybe this will be genuine or non-genuine case bot because I have a safe contact with me and I'm talking to a bank guy like I personally apply for a loan and we are discussing our OTP. But unless will not get a reasoning for that, I will never know like, hey, this is like a proper case for me or like misleading case for me. But after explanatory, like with the help of SAP and Lime, these are tools like used for deep model transparency. We'll talk about these tools in the later slide. It helps us to understand the reasoning part. That what is the credit card fraud he talking about? Like what a conversation going on with the bank, and with the help of like small fragment of the communication, it helps. This tool help us to identify this sort of like whether it's a real problem for a user or it's just. So with the case study, say like it's investigation time down to 40-60%, false positive cut down 60%, and RBI increasingly required moderate audit and customer. So also like a lot of government firms involved in this, and they're trying to help us on this finance because this is something a big issue in India market as of now. Like, and I'm in Samsung like working on some philosophy on this, and so case study I gone through and I find it very interesting. The links in the below slide, and you guys can go and find the detail about. I just put up crust on this, like I didn't put a full slide on that. Security, because this is one of the topic like we talk about IoT threat and botnet detection. Before explanatory, AI detect analogy detector works in lab but failed in production. Ignore alerts. So give me a very good example of this, like and just click in my mind, like, and I want to share with you guys that suppose like in the IoT devices in my home, and I got a delivery message from my phone, and I set a routine for my device. Hey, whenever I got a message from the delivery guy, like, hey, open my like electronic like IoT device in my phone, and somebody can enter and deliver the goods for me. This is the normal principle for me. AI system help us to identify like my WhatsApp message, my like delivery message pattern, and then
Sir, I
help
would
us to
like to
open my
interrupt here, sir.
yeah.
Sir, are you on case study page on your PPT?
Yeah, right.
Okay. Because the participants are writing, they cannot see your PPT, sir.
Oh, really sorry. So right now you guys on a case study page?
Sir, I can see that.
Okay. So
Okay.
I covered healthcare and
Continue,
finance.
sir.
Now I'm talking about security now. So we all on the same page, right?
Yes, sir.
Okay, sound good. Okay, thank you. So let me again so we got a small interrupt. So let me go again so AI system developed for us in the IoT environment where it says like, hey, based on my like SMS pattern on my device, like the delivery pattern, open my electronic gates and deliver my goods for it. So understand this is a like AI system developed for us. So next time onwards, like if my AI system, we develop a system, IoT system like this, next time any routine comes or like this pattern comes, and any WhatsApp message coming from me might be like my AI system will detect like this, hey, this is something, deliver message, and then it deliver for me until it doesn't know like physically I'm at my home or not. Because there's no reasoning for that. I hope you guys understand this. Like there's no reasoning fact on this, like, hey, message is for delivery message. It will deliver from my home. I open my like pattern for my unlock pattern, but physically I'm not available at home. I set this routine because I want to like invoke that AI system. Without the reasoning of that, next time onwards, like if suppose like without explanatory this happened, like with explanatory, if it gives a reasoning for me, hey, you got a message delivery, and then you want to like set up, and we feel that it's not a home, like I'll not allow the AI system to work for me because it just prepare a routine for me. That routine will be a security issue for my side. So that's what like we talk about like that for sometimes difficult, and with explainability, XI model provides test drive audit trials. So it helps us to understand the rule based and identify XI model. This helps us to trust AI system a lot. So we can provide an automated defense on this. And we can invoke a lot of automation based on the understanding that we are the reasoning for this, and we can take some security decisions. Last but not the least, like we'll talk about the tools and techniques. Some of the tools I have gone through, like Lime, SAP, and GradCam. So this just a basic understanding I have gone through with the tools, and then there are a lot of other like Deep SAP and quantity like SAP. A lot of tools developing now in the explainability area. Let me talk about Lime. So it's local interpretable model agnostic explanation. How it works? It's create a local linear approximate around specific prediction to explain black box model. Because as we have seen in the previous slide, like we talk about like what is black box problem, where we see the bank loan, it's saying rejected or accepted, and without the reasoning, we don't know how it works. So all this Lime tool will help us to as for a tabular data, desk classification, and image classification. Advantage is like this is model agnostic. It will work for any model. Like if you guys developing like SVPM, random forest, or small level model, like where you want to understand actually the reasoning of that, you can just embed in the same pipeline. You can embed this explanatory tool, and it will help us to give a reasoning of that. Limitation is completely expensive or large data. It can work a small data, like it just you can say with a very layman example, like if I say it is a dog, like just one sentence for me, and how this Lime tool works, it's break the characters into and start like putting in the AI system. So it say it remove it. Still we have is a doctor is a dog. So it identify is animal versus non-animal. So because is a dog is there, it's data as animal. If I remove is a, it's fine, like it still is as animal. The moment I remove dog, it says non-animal. So this Lime will help us to provide such type of reasoning to us where we have simple sentence, we can take out a meaning of that, and we can find like dog is very essential part in this data set. And when we say dog, somebody can understand, hey, when I get an answer like a dog, I know this is talking about animal now. This small sense of things, like it can work easily with the Lime. So how it works, like you have a model. After the model, you can have a Lime library that's in the Python, and with the Skykit like learn integration, you can integrate in the model, and then once you embed the model, the character get break down and start like accessing all your AI system with the reasoning with the end user, and they can understand what they're talking about. Like when they say it's an animal or not animal, it signifies because of dog they are saying animal. Just a basic example. This is how the Lime tool works for the explainability. Same for SAP. SAP says like SAPLay. Adaptive explanation. When we talk about a Lime, it's for small data. But what SAP says like is use game theory to assign contribution score to each feature fairly. As for the feature importance, like complex non-linear relationship, fairness analysis. So advantage may be like it's sound on the cooperative like game theory, fairness consideration, work across model types, produce both local and global expansion. So we talk about a bank loan in the previous like pages. We talk about there's a lot of conversation going on. So when we talk about the bank loan, it's just not based on only loan. It give a weightage to us and hey, say like this is a problem for the rejected or not or accepted. It identify all the feature around that communication and give a weight score for that. And once based on the like probability of the like, high like the feature we use like in that, and then it gives a lot of meaningful. Like take example of like we want to buy a property. Then when we say property, it might be on the prime location. It might be on like nearby, like we have a expressway, and we have so many things features are there. So it identify all the features and give output us. But in the case of Lime, it's identify on the basic things like, hey, we have one sentence, we talk about this, and it understand and give a result. So it's a basic reasoning. It works with the complex reasoning. That's up. When we talk about the GradCam, it's a gradient weighted class activation mapping. How it works is use like gradient information from CNN to generate visual explanation heat map. So if we talk, just take an example of one, like maybe the lung cancer. I'm taking like case study, the lung cancer. So when we say lung cancer, if we pass it a line tool, it divides that one image into 4 quadrants. And whatever quadrant it fits and say like where the data signifies something, it say like it help us identify the lung cancer. But when we talk about SARP, what it goes like, it's if a feature behind this like lung cancer. Maybe the area nearby is not a like safe area for us. There's a pollution, there's a lot of factors that affect our lung cancer. Not only the based on the like image or something we identify. When we use GAD-CAM, what it does is like it have that image. In that image, it highlight the tumor part and highlight as a red color. And all other necessary other features will mark as a orange some other color. So it's well suited for the vision part. Where we have images where we want to identify something, GradCam is like best source as an explanatory tool for us. So it's best for computer vision, image classification, object detection, medical film. It's fairly work with the visual and interactive for non-technical user because you don't need to understand like say, suppose I'm like as a novice user, I don't know much about this cancer part, but it helps us to identify the heat map. So I can also try something and do some reasoning and understand it how it works. So it's also available in the PyTorch, like, and you can use like PyTorch, and then you can embed in your pipeline for the AI model development. So till now it's clear. Like, sorry, like I'm going a little bit like fast. Maybe I don't know because I didn't get a response on it. Till now, I think we have a pretty much fair idea about like explainability versus non-explainability, how it works. So are you guys with me? Like, I think it should be good interactive session like that. At least say yes or no. You are with me? Like, you guys are understanding?
Yes, sir, we are understanding.
Okay, sound good. I think I got one voice. That means like I'm good. Sorry, like this word.
Yes,
But I
yes,
think
sir.
I'm just trying to, because this is not an easy subject for all of us. This is something difficult, and until we'll not do something hands-on practice on this, it's difficult to explain everything on a slide base. So if you guys have any queries or something you want from my side, please post me an email or maybe like you can text me up. I can help you to understand it more. So because we guys are working on security aspect a lot now, so we can help you in at least like when you guys doing something hands-on or me trying something, we can definitely help you on that. So last
Actually, sir,
like
we are muted. We are muted actually, so that's why we were not responding to you when you asked the question.
No. I think I really like one thing. I'm taking a positive and I'm taking negative both aspect, but I'm taking a positive way because somewhere like you guys with me and you guys are listening and very nicely, very quietly. So I really appreciate for that.
Yeah, thank you.
So conclusion, like from transparency, trust the future of secure AI. This is very important. Like if we don't have a transparency, what AI system build up us, we can't trust on them. I think you guys agree with me. Like without transparency, without getting a like some reasoning insight for that. Sorry. Can you hear me?
Yes, sir, but your
Hello?
screen is actually gone
Yeah,
black.
just a moment. Like it's just crashed on my system. Like really sorry. Now you can see it, right? Is it visible?
Your screen is not visible, sir.
Just give me a moment. Sometimes it's taking time to connect it. So I think might be like this. Just give like 20 seconds. It will visible for all of us.
Okay, sir.
It is visible now.
Not yet, sir.
Just give me 1 minute. I'm just setting up now. Is it visible now?
Yes, sir, it is visible.
Really sorry. Like something get like Microsoft, some error coming. Just to recap now, because we got disconnected now. So we understand like with the help of example, like how explainability without explainability, it helps us in the AI system. We didn't talk about the AI system a lot because I know you guys are like well about the AI system, how it works. So when we come to conclusion, we need to understand that what is the future for secure AI from transparency to trust, because until it's not transparent, like the outputs coming from the AI system is not transparent for us, like very difficult to build our trust. When we see the medical example, like we know that doctors cannot trust on the system because unless they don't get a transparency, like what outcome coming, what's the decision they taken, how they're taking decision, all the data they have taken. So everything will become on place. Like that's why the explainability is a bridge between the AI's capability and the human trust, because unless we don't have any reasoning on that, we understand the tool of lines up and like grad and all, like we understand that how this tool really help us to build a system. Without transparency, AI system remain black boxes that nobody dares fully deploy. We have seen that it all like black box because we just rely on somebody who developed the AI system, and we need to like always trust them, believe them, whatever they prepare is good for us. But with XAI, like we call like explainability as a XAI, organize and achieve three critical outcomes simultaneously. One is operational efficiency, regulatory compliance, and genuine stakeholder trust. So with the figure, like you can easily see, like if we remove explainability, we cannot have trust, security, and compliance with us. So we always need explainability in between to build up that trust, security, and compliance. Very similar, like when we're building the AI system, if we cannot add in the AI system pipeline, if we cannot add this explainability as a pipeline part, we cannot have like fully secure AI system then. I hope you guys understand it well. Thank you for my part. I'm like my privilege